Hey Titans, this is Mordecai from GamerTitan.com. In this video, we're going to be going over a new type of data transfer that Core just introduced in the latest patch. Now, if we hop into Core here, if you've seen my older videos in terms of me talking about how to use broadcasting, how to use network custom properties, and then more specifically, how I was using network custom properties to be able to get data to a specific client. So, meaning if for example, a player loads in and they have something in player storage, currently you can only get that from the server. And so if it's something such as cosmetics data, like what outfits does the player currently have unlocked, if the client needs access to that, such as maybe you're showing a UI or something where you need to show what actual cosmetics they currently own, which ones they can equip, stuff like that, the client needs to have access to the data, which is currently only on the server. And so how I was dealing with that in the past was I was using network custom properties, and I'll just hop into the code real quick. Basically, I would spawn in an actual object that had a network custom property on it. Then I would set the network custom property to whatever the data I wanted to send to that particular player was, and then I would actually name the data object the name of the player's ID. So this was on the server. And then on the client, it would be listening for a child added event. So I would basically add all of those objects when they were spawned in. I would put them all under the same parent. And so with the child added event, you can listen to when a new child is added underneath the parent. And the cool thing about it is that the actual parent doesn't even need to be networked. And so when a child was added, I would then check to see if the child object's name was the local player ID. And then if it was, then I would go ahead and then grab the data from the custom property, and then I would do whatever I needed to do with it on the client, and then I would broadcast to the server to go ahead and delete that object. And so that was the best method that I came up with at the time prior to this new data transfer to be able to send a large amount of data to a specific player. Now, unfortunately, by doing this, when you're using a network custom property, for this particular use case, network custom properties, when they're updated, they are sent and replicated to all clients. And so with the use case that I'm demonstrating here, even though this particular client is the only one that would grab the data and actually do something with it, on the networking front, the actual server would still be sending that data to all clients. So all clients would use some networking, getting all that data, and then they would simply just ignore it. So with the new system that Core came out, it's called private network data. And what's unique about private network data is it's very similar to network custom properties in the sense that you can send all sorts of data types, such as a string, you can send integers, float values, and now you can even send tables directly across, which I believe currently is unique only to private network data, which is very cool. And the best part about it is when you use private data, it's sent only to that specific client. And so you don't even have to do any of this stuff anymore. You could just go ahead and use private network data, and it's better on networking because it only sends it to the client that it's intended for. And so it's very powerful for being able to, for example, load a player's storage in, and for the information that you need on the client, you could simply go ahead and send your storage table across private network data, and then on the client, they could go ahead and grab it and they'd have access to that same table. So it's extremely powerful, and it just came out. So let's go ahead and hop into how I would change my old data transfer on how I was doing it before to this new system. And just as a recap real quick, all this project does is when you join the game, when a player joins the game, it will spawn in that object, and then it will add the string test data for video. And what this is actually being printed out is the client is actually grabbing this. So it's that old method. Unfortunately, like I said, if there was multiple players, all the players would get the data for every player. And so it's kind of a waste of bandwidth for the server and each client that would have to get it. So how would I go ahead and change the current system to use this new method? So similar to network custom properties, there's this new, so we can just go ahead and delete all of this. There is a new function that is set up very similar to a resource, which several creators, probably most creators, have used, probably more so even than the network custom properties. And so it's set up where you take the player and then you just pass in a string value or a string key. So for example, if I just named it data, and then I could pass in, sorry, this window is massive. 1 second. I could pass in whatever I wanted. So say that I passed in, test data for video. Now, once again, I'm passing in a hard-coded string, but you can pass in integers, you can pass in whatever you want. And so you can even pass in tables. And so the other thing is on the client, you would listen just like a resource. You would listen for a change event, and then you could check what key changed and then grab the data based on that. So for example, say that I did data 2 as well, and then we'll just do, this is data 2. Right, and so go ahead and delete all of this stuff. And so all that's gonna happen now is, and technically I don't even need any of this. Like it's very, very simple. And so a player is going to join. It's going to set their private network data to these two things. It's going to set data key 1 and data key 2. And it's going to be both strings. And we'll do better examples of different data types here in a moment. But then on the client, what we need to do is clean this up. Let's get rid of all this. So what we have is the local player. And so just like resources, first off, there is a change event. And so what we can do is we just pass in local player, and we can do on, make a function on private data changed. And then we pass in the player that the data changed, and then the key, which would be the string that we set up in the other on the server. And then what is unique about private data versus resources is it won't directly pass the value that changed that I'm aware of. It will only pass which player's data changed and what key was changed. And so then what we have to do is to actually grab it. We'll do value. We'll pass in the player. And then we pass in the key. And so now this is how we actually grab it. So it's get private network data, and then the actual string or the key that changed, and then the player that was. And so now we have the value, so we can actually do print value. And one thing we probably want to do, because there is a chance that this actual networked data change event doesn't in fact connect in time to actually grab that change, what we could do, let's go ahead and see if it works first. So just as a recap, it's as simple as this. A player joins, sets two keys, data and data 2. Data is going to be test data for video, which is a string. Data 2 will be data 2 grabbed. On the client, we just simply set up the listener, private network data changed event. We connect it, we pass in the function. That actual listener will pass in player and key. We then grab it by doing value equals or whatever you want to call the variable that you're going to store it as. We just go ahead and grab it from the key. In this case, we're just simply going to print the value. So we should see something very similar to what we had before, with a lot less code and a lot better networking. So let's go ahead and load this up real quick. And as I suspected, the listener didn't connect in time, so it actually didn't get the change. However, what we could do is we just do int. And there's another function that allows us to get all the keys of the player. So what we can do is do function init and I think this returns a table. So we do for, so I'm not sure how it passes it back, to be completely honest. So we'll see if it does it like this. Key in pairs do, and instead of player, we're going to pass in the local player. And what we'll do is we'll use key here. And so what we're doing is when the script first loads in, it's doing the initialization function. It's going to loop through and grab all the player network data keys, and then it's going to grab the value for each of those keys, and it's going to print it out. So we'll see if this works. I'm not sure if key is the first value or second, so we'll find out. So that did in fact work. So as you can see, it printed test data for video and data to grabbed. So it was as simple as that to grab the data. And so one thing we could also do is we could just go ahead and comment out this function. So it's actually not even going to run this loop. And what we could do on this side is we could just, now this isn't recommended, this is just showing that we'll do 5 seconds. So why we're adding a task.wait on the server is we're going to allow, when the player joins, the server is going to fire this event first. As soon as the player connects to the server, it's going to fire this. And then that means that the client may or may not have loaded in time. So this listener may not have connected on the client to actually listen for this change. And so we'll actually do this. We'll put a task.wait in between this one as well. So there's a slight delay on the printouts. And so by adding this task.wait, we should have enough time for the client to load in and then be able to see this listener right here should be able to connect and then should be able to print out just from this function. So what we'll do is go ahead and press play. Okay, so there's the first one, and then in 2 seconds, you should print out the next one, which it did. So that's just a quick demo showing that that test actually does in fact work. So another cool thing, which I mentioned, which is unique as far as I'm aware to private network data currently, is the fact that we can pass an entire table. So for example, we can do temp table, and we'll just do, let's say name. Now there's not really a reason to do this, but this is just a demonstration. We'll do time. And we just do like player count. So like say we add count equals 0. Now once again, there's no reason to do most of these things that I'm adding. However, we can do count equals count. And this will show the player count, and then we can pass the temp table directly to data. So now we will need to change our code slightly. So we'll go ahead and open it this way. Sorry about that. So now on the client, we're actually going to be getting a table here. So we're going to get rid of this. And so now this will be table, and we can print table.name would be the player name. We can print table.time, which would be the time that the player joined on the server time. And then we can print count by doing table.count. And we should be able to see all of these. And we will put the delay. Yeah, we'll leave the delay there. So now this should work. So we're basically passing a table. We're creating a table called temp table. And then we are passing temp table into data. And the reason we change this to table is just so we know that we are getting back a table. And I'm setting the table to have name, time, and count. And we're printing out table name, table time, and table count. So really table name will be the player's name. table time will be the time that they joined, and the count should just say 1 because there'll be 1 player that joined in this particular example. So we'll go ahead and press play here. And then I will look at the event log, and it printed it out. So it printed out bot 1, it printed out 1452, which is the amount of seconds that I've had the core creator opened, and then it printed out 1. And so being able to pass tables directly is very, very powerful. One thing I will mention, however, is if you are passing direct tables, every time you need to update that entire table, if you pass it again, so say that we passed temp table and then later we changed something about the table and then we wanted to send it to the client again, if it's a fairly large table, every time we are resetting the table in the private network data, it sends the entire table again to the client. And so that's just something to be aware of. If you're sending entire tables, it's probably good to send it once. If it's like from player storage as an example, you can send it once and then cache it on the client. And then in future actual updates, I would just update the key directly. So I would actually update I would change, instead of passing data, for example, I would change it to the actual key. So for example, I would change it to like name, and then I would pass player name. And then on the client, you would listen for that and then update the table. That way you're not replicating entire tables. But I don't want to say too much because I don't want you to be too fearful of stuff, because this is extremely powerful. There are a few downsides. One of them is private network data is a very low priority in terms of the networking, as far as I understand. So that means that if there's a lot of activity going on the server, where there's a lot of networking being used, and you're trying to set private network data, since it's pretty low on the priority, a lot of the other things that are using up the bandwidth or the networking capabilities of the server, those will go first until things start to settle down. Then it will try and send the private network data. So just be aware of that. However, because of it being able to send directly to one client, this is very, very powerful in terms of networking compared to using network custom properties for everything. Now, there's a few other things I can mention. One of them is, I believe, now don't quote me on this, but I believe that you can store 25 kilobytes of data in the private network data. And once you cap out on that, if you keep trying to add more stuff, then it will give you some response codes, such as success, failure, or exceeded the size limit. So if you start adding too much data, which 25 kilobytes is quite a bit, that's an entire storage key, almost 2 entire storage keys packed full of data that you can send across from this. It would be good to start nilling out private data. So for example, once you sent the key, or once you sent that table, just to go back to the other example, say you send this entire table and it's using a lot of data, and then you can nil it out. And I believe that you would get because you nilled it out, then you would have access to more space. So if you sent like an entire storage key to a player and then you know that the client got it, then I would nil that out if they didn't need it again. That way you could use it for other stuff in the future instead of just having it sit there. But that's totally up to you. So like I said, I don't want to say too much to make creators nervous to use this, because it's unlikely that you're going to be able to burn up 25 kilobytes unless you're just slamming this thing full of stuff, depending on your game. And so once again, this is a newer type of, this just came out in the last patch, and this is something that I'm going to be using in a lot of things. So for example, I used to use resources for quite a bit of things. For example, one of our games, Heroborn, way long time ago, I used resources and I had a whole key system, and then basically would use the integers as the key of the item. What I didn't know is that because that particular case, only that particular player needed to know what items they had, it was replicating to all the other clients and it was using a lot of data. So things that I use that needs to send data from the server to the client, I'm always going to be using private network data, or I should say the majority of the time, if it's only the local player that needs access to that particular data. Now, if it's something where other players needs to know if another player has something, I would still use resources and I would still use network custom properties depending on what it is you're trying to transfer. But this is extremely helpful, once again, for getting stuff from the server to the client if they're the only ones that need to know about that data. So hopefully this video was helpful. There's likely going to be a few questions, so if you have any questions, please leave them in the comments down below. This is a very new system or a new feature, and as I use it more and more, I'll learn more about it and try and update everyone on, as I learn, I'm going to try and update everyone on what I've learned in use cases in the real world on how I'm using this and any pitfalls I might find in using it as well. So go ahead and try this out. I hope you enjoyed this video. Please leave any questions and comments down below. Hit that thumbs up and please hit that subscribe button if you want more core related content. I'll catch you next time, Titans.